Yes, last class we studied the addition of vectors, different method for adding two vectors. Today we are discussing the subtraction of vectors. Subtraction of vectors. How to subtract a vector from one vector? Subtraction. Actually, there is no method to subtract a vector from another vector. There is no special method to subtraction in vector algebra. Then what we do? Instead of subtraction, we use addition. We add the negative vector of the second vector. We got the result. That is, if suppose we have two vectors, vector P, you can take A and B. Suppose we have two vectors, vector A and B. Subtract B from vector A. Vector A minus B are equal to vector A minus B can be written vector A plus minus of vector B. You know how to add two vectors. You studied the addition of vectors, different method, graphical method, analytical method, etc. In graphical method, triangle law, parallelogram law, polygon law, etc. We can use any method and add the two vectors. What is the condition? Take the opposite vector of the second vector. Opposite vector, also called a negative vector. Okay. For example, we have a vector P and a vector Q. How to add these two vectors? Suppose using triangle law. Without changing direction, take this Q and put the tail to head of the P and draw the third side of the triangle and take the opposite order. We got the resultant in magnitude and direction. Here, first we find the negative of Q. What is negative of Q? This is vector Q. Then negative vector Q is equal length and opposite direction. This is magnitude minus Q. Then we can subtract, we can add P and minus Q. This is minus Q. Okay. That is vector, this is vector P, I redraw P, minus Q, this is minus Q. Then the third side taken in opposite order. This is the order. Then opposite order is, this is the opposite order. This vector represent R equal to P plus or minus. Yes, minus Q. That is the difference. P minus Q. Then what is P plus Q? Plus Q. This is minus Q. This is plus Q. This is plus Q, isn't it? Equal and opposite. Using triangle law, the third side represent R equal to P plus Q. Okay. Then what we do for subtraction? We just add the negative vector. Now, actually there is no important for the subtraction. Then why we study this subtraction? It is only for relative motion. What is relative motion? Relative velocity. You know, motion rests all are relative. A body move with respect to another body. A body is said to be rest with respect to another body. Relative velocity means the velocity of a body with respect to another body. You studied in the straight line. What is relative velocity? The velocity of a body with respect to another body. If the first body is at rest, we say just velocity. Okay. If the velocity of a car is 40 km per hour, what is the meaning? The velocity of a car with respect to the road is 40 km per hour. But the road is at rest, therefore we simply say the velocity of the car is at 40 km per hour. If the road is moving, if the platform is moving, then the velocity is a relative velocity. It is called a relative velocity. Okay. If a train is moving and a boy is running through the running train in opposite direction, then the velocity of the boy is relative velocity, like that. Suppose we have two bodies A and B. The velocity of A with respect to B is called the relative velocity of A with respect to B, VAB. VAB, it is a vector quantity. VAB equal to vector VA minus vector VB. Velocity of B is subtract from velocity of A using subtraction method. Okay. If we have to find relative velocity of B with respect to A, denoted by VBA. VBA equal to velocity of B minus velocity of A. Okay. Thus, the importance of the subtraction is when we are considering the relative motion. Okay. Next, you studied addition and subtraction of vectors. Multiplication also but we study the multiplication in the 4th chapter and 5th chapter. Two methods, dot product and cross product, we will study later. How to multiply a vector by a number or a scalar. Number and scalar are same, both have same operation. Suppose how to multiply a vector by a scalar or a number. Very simple topic. How to multiply a vector by a number. If we have a vector A, we have to find 2A. What is 2A meaning? 2 into vector A. Vector A is multiplied by a number 2. We just draw a straight line double that of A and put the direction. We got vector 2A. The condition is 2 is a positive number. If we want to find NA, then NA equal to, first we draw n times magnitude of vector A. That is, the length of A is multiplied by n. Draw the line and put the same direction. We got the vector n times A. Okay. Magnitude is n times magnitude of vector A. N into modulus of vector A. Direction, same direction. What is the direction? Same direction. Okay. One more case. If n is negative, If n is negative, n negative means suppose minus 2a, then magnitude is same but the direction is opposite. If n is negative, then the magnitude is n times the magnitude of a, and the direction is opposite to the direction of vector a. That is how we multiply a vector by a scalar or number. Okay. Suppose we have a velocity v. What is the double of the velocity? What is the double of the velocity? Just multiply 2 and magnitude of velocity and put the same direction, we got the resultant velocity vector. If we multiply minus 2, then the direction changes opposite. That only the difference. Okay. The resolution of a vector. Okay, you already studied the addition and subtraction of vectors in different method. Now we discuss the resolution of a vector. We want to apply in many cases throughout in physics. Not only this chapter, not only in first year, throughout the physics we use this resolution of a vector. Now the resolution of a vector. Resolution means splitting a vector into its component is called the resolution of a vector. Splitting, for example, in numerical value we can split, suppose we have a value 10, we can split into 2, 5 plus 5, this is the only way to split 10? No, we can split is 4 plus 6 or 2 plus 3 plus 3 plus 2, this is 10, also 1 plus 8 plus 1, in number of ways. We can split into a number of fractions. Like that we can split a vector into a number of ways. That is called a resolution. Splitting a vector into its component is called a resolution of a vector. We can see one method of resolution called a rectangular component of a vector. Rectangular component. We can split a vector into two mutually perpendicular components. A vector into two mutually perpendicular components which are lying in the same plane. That is called rectangular components of vectors. Then what is rectangular components of vectors? The components of vector which are mutually perpendicular and lying in the same plane. Any vector can be split into rectangular components. For example, here we can see a vector P. This is vector P. This vector P can split into xy plane. How? Just draw like this and split. We get one component in x direction, we can write as px, and one component in y direction, that is py, px and py. We can split the vector p into two mutually perpendicular components. Px and py are 90 because they are lying in the xy plane in x and y axis. Okay. Then this px and py are rectangular components of p. We can write vector p as vector p equal to px plus py. Vector px plus vector py. We can also write vector p equal to vector px I cap plus vector py j cap. What is the meaning? Px is the magnitude of vector px. the magnitude of component of vector p along x direction, and I cap is the direction. This is magnitude, this is the direction. Magnitude into direction, that is the vector px. Like that, py and j cap. J cap gives the direction of y. Okay, that is vector p is equal to pxi plus pyj. What is the magnitude of vector p? Magnitude of vector p, case 3, we studied in case 3, that is modulus of px square plus py square. Check the analytical method, third case. This is the modulus. Okay. If we have one more component in z axis, that is pz, then we can write in 3 dimension. Just p equal to px I cap plus py j cap plus pz k cap. We can write any vector in this method. Suppose we have a vector A. This vector A can represent as ax I cap plus ay j cap plus az k cap. Ax, ay, az are rectangular components in 3 planes. Okay. Vector b can written as vector b equal to bxi cap byj cap bz k cap. Okay. This is the method of representation of vectors in 3 dimension. If it is in 2 dimension, we can cut this portion, z portion. That is k cap represent the direction of z. Okay. Next, motion in 2 dimension. We are studying the chapter motion in a plane. That is, it is a 2-dimensional motion. 2 dimension means 2 coordinate will change. In 2 dimension, the displacement is represented by position vector. The position vector is the displacement from the origin. This is the origin. This is x coordinate, y coordinate, motion in a plane. That is 2 dimension. We have 2 coordinate, x coordinate and y coordinate. This is the reference point O. If the vector p is here, then the position vector, we can draw the position vector from origin to p. P is the position. We draw a vector from origin to p called position vector. It is denoted by r, vector r or r of t. In mechanics, all are function of time. We can write r of t, x of t, v of t, a of t, like that. You already studied in the first chapter. That is r of t, or simply vector r is equal to r of t is the position vector. What is position vector? The displacement from origin to that point is called position vector. Okay. We can split the position vector p into 2 component, rectangular component. One is called x of t, this is the x component. Second is y of t, y component. How we split these vectors? Using triangle law or parallelogram law. We can apply triangle law or parallelogram law. Here we can write r of t equal to x component x of t plus y component y of t, or simply vector r equal to x into I cap plus y into j cap. R is the position vector, x is the magnitude of component of x direction, I cap represents the direction of x, and y is the magnitude of component of y, and j cap represents the y direction. This is the representation of a position vector. Position vector can be represented as R equal to xi plus yj, xi plus yj. Okay. Then rectangular components of velocity. In two dimension we have two velocities. One is towards x direction and the second one is towards y direction, because they are in a plane, motion in a plane, two directions. We can split the velocity. This is the velocity vector. This velocity vector can split into vx and vy. Then we can write velocity v is equal to velocity v equal to vector vx plus velocity vx plus vy, or vx into I cap plus vy into j cap. Vx is the magnitude of velocity in the x direction. Vy, look here, Vx is this is the net velocity, resultant velocity in two dimension v. We split the v into Vx and Vy, two rectangular components. Vxi plus Vyj. Vx is the magnitude of velocity in the x direction. Vy is the magnitude of velocity in the y direction. I cap represent the x direction and j cap represent the y direction. Then this v can written as v is equal to vxi cap plus vy j cap. Then what is the magnitude of v? Magnitude of v, we can write simply v is equal to simply v or modulus of v. These are same. V is equal to root of vx square plus vy square. How we get? Yes, using the third case of analytical method. Okay, because vx and vy are at 90 degree. Therefore, v is equal to root of vx square plus vy square. This is the magnitude of velocity. Magnitude. Then what is the direction of velocity v? What is the direction? Direction is theta. Okay. Direction is theta. Find tan theta. Tan theta equal to y by x, y component by x, y component vy, x component vx. That is, we can always apply this method to find the direction. Y component by x component. That is how to find slope v by bx. Y component by x component. Tan theta equal to v by vx, or theta equal to tan inverse vy by vx. Then in two dimension, the magnitude of velocity is root of vx square plus vy square, and angle is, or direction is, tan inverse vy by vx. One more. A rectangular component of rectangular component of acceleration, not velocity, acceleration. Okay. In two dimension, there are two accelerations, one in x direction and the second one in y direction. That is, the acceleration A can be, A is the acceleration, it is a vector quantity. It can split into two rectangular components, ax and ay. Split the vector A into x direction and y direction. Okay, using triangle law or parallelogram law. How to apply triangle law? This is ax, this is ay, ax plus ay equal to resultant A, opposite order. If we apply a parallelogram law, ax and ay are adjacent sides of a parallelogram, then the diagonal is the A. You can apply any theorem. Then vector A can written as vector A equal to ax I cap plus ay j cap. In two dimension, the acceleration can be written as A is equal to xi plus ayj. Okay, magnitude of acceleration modulus of A, or simply A, equal to root of ax square plus ay square. This is the magnitude of the vector A. Vector A is the acceleration. Okay. Now direction, tan alpha, tan theta equal to, here we put theta as the angle between a vector and a resultant. That is, this is the resultant. Yeah, we split this ax and ay. Tan theta equal to ay by ax. That is, theta equal to tan inverse ay by ax. Please note, always we can find the direction tan inverse of y coordinate by x coordinate. Always theta. Direction is, if we split the vectors into rectangular components, then we note the point tan inverse of y coordinate by x coordinate. If it is velocity, vy by vx. If it is acceleration, vx by ay by ax. That is the direction. And magnitude equal to root of x component square plus y component square. If it is velocity, vx square plus vy square. If it is acceleration, ax square plus ay square. Okay. Suppose one more thing. First was, we have a vector, suppose it's velocity v, making an angle theta with the x axis, and we split the vector into two components. One is vx along x direction and the second one vy along y direction. That is rectangular components. Then we can write a velocity v. Velocity v equal to vx I cap plus vy j cap. Okay. Vx equal to, how to find Vx? Take cos theta. What is cos theta? Theta is the angle between V and Vx. Cos theta equal to opposite adjacent side by hypotenuse. Adjacent side Vx by hypotenuse V. Then Vx equal to, we got V cos theta What is Vx? V cos theta. V cos theta. Then how we get Vy? Yes, take sin theta. Sin theta equal to, this is theta, opposite side. What is the opposite side? This is Vy. Same vector Vy. That is opposite side Vy by hypotenuse V. Then what is Vy? Vy equal to V sin theta. Vy equal to V sin theta. V sin theta. Okay. V sin theta. Important. We can split a velocity V into V cos theta and V sin theta quantity into two components in two dimension. One component is cos component and a second component is sin component. This is V cos theta. It is called a horizontal component, commonly called a horizontal component of velocity. This is called a vertical component. V sin theta is called a vertical component. Vertical components. Okay. Suppose this, if it is acceleration or position vector, first we study the position vector. This is the position vector R. If the angle theta split into R, Rx or simply X. Position vector we can just denote X and Y. X and Y. Then what is X? X equal to R cos theta. Same method. Y equal to R sin theta. R sin theta. This is the horizontal component. This is the vertical component. Okay, in two dimension. If it is acceleration, if it is a, then this is Ax. This is Ay. Ax equal to A cos theta. Ay equal to A sin theta. If we have a force, we can apply it into problems. If we have two forces, F1 and F2, suppose if we have force F, we can split into two rectangular components using triangle law or parallelogram law. This component is Fx, this component is Fy. Take the angle theta between Fx and F. All are vectors. Then Fx equal to, simply magnitude, Fx equal to Ef cos theta. Fy equal to Ef sin theta.